Thank you for joining me. My name is Eduardo Herrera, and today we're going to examine the TCP IP model that is a protocol suite driving the Internet. Let's go ahead and take a look at the objectives for this presentation. First, we're going to get a little bit of a history of the TCP IP suite. Then we will illustrate the use of application protocols in the TCP IP suite, and then make a comparison of TCP IP to the OSI model. Then lastly, we will go ahead and describe the RFC process, a request for comment, which is used to amend, ratify, and adopt new standards to the protocols. The history of the TCP/IP suite begins back 1969 when a group, the Advanced Research Projects Agency, better known as ARPA, was a part of the Department of Defense, was trying to enable communication across universities and research facilities throughout the U.S. This became known as ARPANET, a WAN network, which is a predecessor to modern networks utilizing Network Control Protocol, NCP, which enabled universities like Stanford and UCLA to communicate. University of Utah later became part of that network, and also IBM got involved. Unfortunately, this communication did not provide a very good, reliable stream and transmission consistency. Unfortunately, with an inconsistent communication transmission stream provided by using NCP, TCP came into play, the Transmission Control Protocol. It is a core protocol of the TCP/IP suite, which provides a connection-oriented, end-to-end reliable network connectivity. In combination with IP, Internet Protocol, which is a connectionless core protocol of the TCP/IP suite, provides packet construction, addressing, and routing functionality. Let's take a look at the advantages of utilizing TCP/IP. It has become, again, the worldwide standard on most networks and the Internet. It does have influences consistency in network design and architecture. It is the most compatible with a diverse menu of operating systems and applications out on the market, and the availability of a multitude of troubleshooting, network analysis, and security tools has no end. Associations with other protocols and applications within these associations allow for the interoperability of TCP/IP with a wide range of communication capabilities. The TCP/IP protocol suite has many similarities with the OSI model. The application layer interacts with software applications. The transport layer function is to provide the reliable transport of data between two systems regardless of the underlying networks in between. And the internet layer primarily deals with addressing and routing. Now, the application layer, the top three layers of the OSI model, are shifted over into the application layer. Now let's compare the TCP/IP stack and the OSI stacks. As you can see, the OSI model consists of 7 layers, whereas your TCP/IP stack consists of only 4. The very top layer, the application layer of the TCP/IP stack, houses the application, presentation, and session layers of the OSI model. Now let's take a look at the governance behind these protocols. The International Engineering Task Force, the IETF, and the Internet Society, these are the primary technical and standard-setting entities for Internet. They use a process of RFCs, or requests for comments, for status designations. An RFC is just authored by engineers and computer scientists in the form of a memorandum just describing methods, behaviors, research, or innovations applicable to the workings within the Internet and its connected systems. It is regularly a long, drawn-out process taking anywhere from 18 months to years to possibly not even doing anything as far as ratification or adopting any of the new standards discussed in this memorandum. In summary, to gain a better appreciation for the importance of TCP/IP, consider this. Anyone using the Internet must engage the TCP/IP suite. Again, TCP/IP uses an older, simpler 4-layer model that lumps the latter 3 layers of the OSI model into a single application and or services layer, but is otherwise very much like the OSI reference model. Then the documents that govern TCP/IP standards and practices are called RFCs, and the process of their creation, development, and approval involves representatives from government, industry, research, and academia. Thank you so much for joining me today. Have a wonderful afternoon.